Welcome back to lesson 2.5. We're now going to look at measures of center. So we did look at the measure of center called the median back in lesson 2.3. But now we're going to look at three measures of center, including the median. And we're going to talk about how we choose which one is best. We're going to kind of be talking about that. So there's three measures of center. The first one is called the mean. A lot of times we will say that's the average. You've heard that before, I'm sure, where we take all the data values, add them together and divide by the number there are. The median, Q2, is the value where 50% of the data falls below and 50% of the data lies above. And the mode is the most frequent value in the data set. So you're just going to count which one occurs the most, and that is the mode. There's going to be a couple different symbols that we're going to use. So the Greek letter mu represents the population mean. And then the symbol X with a bar above it, we pronounce that as X bar, is the symbol for the for our sample mean. Okay. One of the requirements for the sample mean to be a good estimate of the population mean is for the sample to be taken by a truly random sampling method. So that's important. So let's look at how we find our three measures of center. So the following data show the number of months patients typically wait on a transplant list before getting surgery. The data are ordered from smallest to largest. Calculate the mean, median, and mode. There's a link to this data in Canvas, and we're going to calculate the mean and the median using Desmos, and the mode is simply counting which one occurs the most. So it looks like 7 occurs 4 times, 1, 2, 3, 4, 5, 10 occurs 5 times. So it looks like 10 is the one that occurs the most. There's 4 7s, but there's 5 10s. And so 10 is our mode. Okay. The mean is we're going to add up all of these values, and then we would, so it would be the sum of all values divided by the number of values. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. 39. So we're going to add them all up and divide by 39. So let's just head over to Desmos so that we can see that. And for the most part, just entering the data, allowing Desmos to do the work is probably the easiest way to do that. So I'm going to open up the folder with transplant lists, and there's all of my data, and there's the mean. And I'm going to add in I'm going to count how many there are in that list just to make sure I did it correct. Oops. No. I did not mean to do that. I thought maybe that would count those. Well, the mean is 13.958 and the median. So you're just going to type mean and median and then put in the column of data that we're working towards. And it looks like our mean is 13.95. We'll round that to 2 decimals, and the median is 13. And because there's an odd number of data points, 39, that means that the one right in the middle, which would be 19 and 19, and so the 20th data point should be the very middle one, number would be 13. Okay, let's look at our next example. It's books from the library. So it says in a sample of 60 households, one house, go back to my paper here. in a sample of 60 households, one house is worth $2,500,000. Half of the rest are worth $280,000, and all the others are worth $315,000. Which is the better measure of the center, the mean or the median? So I would say the median, because it looks like this one is going to pull everything, because it looks like must be like it says half of the rest, so half of 59, so about 29 of them are worth 280,000. All the others are 315,000. So they're really all around these two values, 280 and 315. I would think that this 2,500,000 is an outlier. It's going to pull it up. So even if we just put in some play data, and let's just say we put in some here, and we did 10 at 315,000. We did some of them. And then we did a bunch more at 280,000. And then let's say we just added in that 2,500,000. So if we did just this and we said the mean of, and that column is X5, so X5. So the mean is very large. And if we did the median of that same data set that we just kind of made up, we didn't do 60 data points, but we did about half were at 315,000, half were 280,000, and just that one, you can see that the mean definitely pulls us towards that larger household. The house that's worth that 2,500,000, which is definitely not representative of the rest of the homes. So that's good to know. So the median, because it appears the one very expensive home makes the mean large. Okay. Let's look at the next one. It says the number of books checked out from the library. There's 25 students, so that means it's odd. So there'll be a very middle one. They want us to find the mean, the median, the mode. So the mode we have to do by hand. It's the one that occurs the most. And it looks like there's 1, 2, 3, 4 7s, 3 8. So it looks like 7 is the mode. And because there's 25, that means there'd be 12 on the left, 12 on the right, and the 13th is going to be the median. So let's calculate by hand and see if it matches what we find in Desmos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 7 is also going to be the median. So let's just go to Desmos and see how this turns out. So books from the library. And we type the mean and the median, and yep, the mean is 6.16. The median is 7, and we already calculated the mode to be 7. Okay, the next data set is this data set on video games. Let's first look at our next question here on the paper. And for example, we're going to look at some things. It says, 5 credit scores. Credit score is a rating that some companies give you, and it tells if you want to buy a house, to get a house loan or a car loan and borrow money for something, it tells the bank how worthy you are of paying back debt. And so whenever you make, if you rent a home, it goes into this credit, the credit system knows if you've made a late payment on your cell phone payment, a late payment on your consumers or your electricity or your heating bill or your rent payment, or your credit card. And so credit scores tell a bank how well you do at paying back your debt. So it says 5 credit scores are 680, 680, 700, 720, 720. The data set is bimodal because the scores 680 and 720 each occur twice. Okay, so that's called bimodal, bi meaning 2. Consider the annual earnings of workers at a factory. The mode is 25,000 and occurs 150 times out of 301. The median is 50,000 and the mean is 47,500. What would be the best measure of the center? So the mode is 25,000 and occurs over half of the time. Wow. The median is 50,000 and the mean is 47,500. So I would say the mode, because I would think the mode definitely represents the data set the best. The mode is the best representation of center. Okay, calculating the mean of group frequency tables. So it says when you have grouped data, you must use a midpoint to represent the classes so that you can calculate the mean. This is going to be called a weighted average. Okay, we're going to use this in a couple different ways this semester. This will be considered an approximation because you're using a midpoint to represent all of the data values within the class. It says Maris conducted a study on the effect that playing the video games has on a memory recall. As part of her study, she compiled the following data. What is the best estimate for the mean number of hours spent playing video games? Okay. So we have to find our midpoint. So the midpoint goes from here because these are rounded down 3.499. We're going to treat it as the highest is 3.5. We're just never going to actually arrive there. So our midpoint is by taking 0 plus the next lower boundary. We talked about lower bounds back in chapter 1 and earlier in chapter 2. So 0 and 3.5 and then divided by 2. And that is going to give us 1.75. And then we're going to do the same thing here. We're going to do 3.5 plus 7.5 divided by 2. So 3.5 plus 7.5 is 11 divided by 2 is 5.5. And then the next one is going to be 7.5 plus 11.5 divided by 2. So 7.5 plus 11.5 is 19 divided by 2 is 9.5. Now it looks like the first one was only about 3.5. These are all going to be 4 apart. So this next one is going to be, you can see that that's the first to the second is a little bit different, but the next one is going to be 11.5 plus 15.5. 27 divided by 2 is going to be 13.5. So these are 4 apart, 4, 4, and so these are going to be 4 apart. So this one is going to be 17.5. And then we are going to go to our video games, and we're going to put in X3, the midpoints we came up with, 1.75, and 5.5, 9.5, 13.5. So 13.5 and then 17.5. Okay. So the next thing that we have to do here is we have to multiply the midpoint times y3. So we're going to actually create a new, you could actually create a new, which is going to be x3 times y3. Times y3. And it will multiply them together. And then we're going to add. So we're going to say sum the, no, we don't want to sum, we want a total. It's total. Total the x3 star the y3. And then we're going to divide by the number of observations. 1, 2, the total of y3. So the count of y3. So the total of y3. And that's going to be our average, 10.78. It's called a weighted average because we're weighting, for instance, the group that says 9.5 has more weight because there's 12 observations in it.